Hey folks, so today we will talk about the local fast and why the local fast is so important for the sovereign data and how we could achieve this setup. Actually, I have the separate videos about the local fast already, but the main idea that all the data stay on your device and this data is the main source of truth. But we live in a world where one device is not enough. So we definitely want to have something more complex. And the local fast doesn't mean that you have the only one device. So we have the multiple devices. And when we have the multiple devices, we want to replicate this data across your devices. So one way is just a central server and good old approach that you store everything on server, but then it's conflicting with the concept of the local fast data. Yeah, so we need some setup, maybe some hybrid setup where you have ability to replicate the data across devices without the central server, or maybe with the help of some relay-like architecture like the Debian do. And how we could achieve it. So it's a lot of the research. We don't need to reinvent the wheel because we have the data types. And data types we have for a long time. So if you take a look what the data types do, they give you the better abstraction and hide the complexity and lower the cognition load. So if you have the data types in your language, for example, so you don't need to think how the float really looks like a bits on your hard drive or in your memory, because you don't need to know about mantissa and exponenta and all other things, or you don't need to think how the strings actually stored in a memory, and different languages tackle it in a different way. So the data types give us the better abstraction. And linear data types, for example, they give us more powerful abstraction like list, sets, maps. And with these types, you could build some kind of collections in your memory, and it's allowed to flip the abstractions, so you could have more effective or maybe parallel friendly types that you don't need to think how they work in a decentralized or parallel setup. And in space, in a parallel and distributed collections, we already have a problem that you could have two instances that may be not talking with each other quite often, or accumulate somehow the different states over the time, and in some point we need to merge these states together and have one predictable state. And actually CRDT, conflict-free replication data types, they actually give us this abstraction that you have the data that know how to merge the different sets together and give you the stable and adequate results. So the CRDT solves the problem that you could have multiple instances of the type that do not communicate with each other, and in some point it's able to merge the status and give you the predictable results. So it's hide from us the complexity of merging the different types. And CRDTs actually, it's a lot of different types of the CRDT. So just to give you the understanding, for example, how the most simplest as possible CRDT work, that you have a simple integer counter and you have the multiple counters decentralized, and you have no control how they work. They could be offline in some point of time, and in some point of time we just exchange the data, merge them together, and get the final value of the counter. So how it's organized? So it's organized quite simple, that you have a map that have the unique ID for every increment, and in some point, instead of just a single value, you just merge this map with the individual increments and count them. So it's super easy. And it's how usually the CRDTs work, that they have couple of stages, but they always have the algorithm how they apply the stage changes and so on. So, and you could have the operational CRDTs where it's easy to have the commutative operations that you just apply the operation log and get the results. But quite often it's not possible, for example, for some complex data like the relational databases, and it's most interesting space in a CRDT and local fast, how to give the developer the tool that he already know, that he don't need to learn some rocket science, math, some complex things, and how to give to the developer just ability to have the local database like SQLite, where he could store all this data and in some point make the system that turn the data tables to the CRDT friendly data tables that allow us in the future just to merge the changes from the multiple database to one database on the device. And actually this project made by Matt and the Vulcano.io and the CR SQLite that actually bring the idea of casual length sets. It's a quite interesting CRDT type together with the last right win register. So we combine these two complex CRDTs and represent the data table as a set of the rows that could be mergeable, and it's quite interesting project. I love it, I use it, and I'm really keen to build maybe something for other databases in the same approach. But content conflict-free replication data type actually give us the powerful abstraction that say that we could be offline in a long period of time, accumulate the changes and merge the changes predictably together. And this is the basic of infinite amount of applications that could do the collaborative editor or exchange the complex data across the devices. And maybe you could have the hybrid peer-to-peer and semi-centralized network where you don't need to go to the internet if you have two devices connected to your home Wi-Fi, or maybe with some Bluetooth connection and all other things. So it's quite cool. It's a huge building block and quite critical for the local fast applications. And at the same time, the local fast applications is a huge and critical for the decentralization and a sovereign data. So I really believe that investment to understanding the CRDTs, the building on top of CRDTs, supporting the open source projects that actually make it happen, like the CR SQLite or LoRa or some other databases that actually use the CRDTs like Ditto, but Ditto is not open source and so on. It's crucial. It's crucial for our future. It's crucial for our independence and sovereignty. So if you want to know more, I will share a couple of links and I will write probably the article maybe next few days. And if you want to know more, just ping me, subscribe to our channel, share this video, and just talk to me in LinkedIn